You got about no, 3 minutes early. Yeah, it's 3 minutes. 10:18 was the published start time. I have a quarter after. I am a quarter after. All right, now a quarter after. So, Bob, the first thing you want to do is introduce yourself and welcome everyone present and otherwise to the September SVFIG meeting, and then on with your show.
Okay.
I will say you stand.
Hey, John. All right. So if you have not already, would you please go ahead and install Telnet on your PC, open up a couple of terminal windows where you can run Telnet, and then Telnet to port 8870 at 10.21.144.127. Yes. Yeah. So.
Yeah, for future reference, use the black one. That's pretty much what we can see.
Well,
Everything else is.
here we go. So, good morning. Welcome to the SVFIG. This is the September meeting for it. Today we're going to talk about just a small utility that you may find useful. I'm kind of hoping that this utility will wind up being something you can add to your software toolbox. You probably don't need it today. You probably don't need it this week. Someday you might. And so I'd like to have you go away from this meeting with it installed on your computer.
Say your name.
Bob Smith is my name. And I wrote software to drive a robot. The robot is a FPGA-based robot with several different kinds of sensors. Bumper switches, ultrasonic distance sensors, even a IR receiver. It also has quadrature encoders on the motors so that we can get an idea of the wheel speed. The software to drive that turned out to be actually kind of a nice piece of software in and of itself. So I converted it into an empty event-driven daemon. It's empty in that it has all the structure and framework, but the actual functionality is added as a plug-in module, as a .so file. Who here has done .so files before? Anyone? All right. I personally make sure, because I'm always a little intimidated when someone says it's a .so file or a plugin. It's like that. It's really easy, and there's working examples, so you really don't have to learn anything, I promised, in order to use this. So let's go ahead and the idea is that I want to give you a demonstration, because a demonstration will actually make it real in terms of what's going on. And it is so simple that with a demonstration, you'll get the whole idea in just a few minutes. Then I'll give an overview where we have some slides and kind of do a little bit more of a thorough walkthrough, but it's only 4 slides, so that's not going to be burdensome. The real goal of today is to download, build, install, and test. Now, you can do make, uninstall, and it will be completely washed away. But if this is going to be a tool in your toolbox, it's something that you've got to leave with working on your computer when you leave today. That said, so who here is telnetted in? Who has opened up a couple of windows and now is telnetted in? One person? That's going to ruin the demo.
This is not a standard public sign network thing.
No, I,
The 10 series is the network here is Galaxy networks.
Yeah, but you're still using their, it doesn't have a Wi-Fi spigot that we're connecting into.
We're still going
So we're still going through Stanford's router.
actually, no, the problem is at this end.
It was there for a
Oh, there it is. Sorry, the USB cable was loose.
There we are.
All right, so if you would, go ahead and try to connect in. Yeah, it'll be easier with two. All right. So the first command to try is called edlist, EDLIST. Okay, looks like that's cut off on the screen, so I'm going to pull this up a little bit. edlist. edlist in this case, wait, sorry, still fooling with the setup. Yeah. Actually, this is going to take a couple of minutes. Whenever you start a program, if it died unexpectedly, there's a TCP wait time. So we've got a couple of minutes before I can restart the program and go again.
So Bob,
Yes.
I have to owe up to the fact that I tried to connect you to this group for the talk. One of the motivators, and maybe I was mistaken, but oftentimes you have these tool chains where everything has to be compatible with everything else. You seem to say that this EEE works with any language.
The reason it does is why I wanted to open up two TCP connections. It's an ASCII protocol over TCP. Anyone can do an ASCII protocol over TCP. It's written in C, and there are no library dependencies. It is specifically aimed for Linux, but I think it would also run fairly well on any POSIX kernel, for instance.
I guess because I know you from the whole Brewer Robotics Club and build devices like this. As a person who likes doing JavaScript, I want to program a robot in JavaScript. The people here want to program it in Forth.
I think if you can open up a TCP connection and write ASCII characters down that connection, this is a nice tool for you. It's something you ought to have in your toolbox. You might not need it today. It's event-driven. Everything is done in a callback. So you set everything up, and then the system itself drops into a loop, a main loop that you can access if you want to modify the code. But normally, all activity occurs on timeouts or on file descriptor activity. Earlier, I mentioned that on the robot, there's quadrature encoders, there's a bumper switch, there's an IR receiver. All of these sensors typically want to be broadcast out to multiple receivers. A good example of that is the wheel encoders. You use the wheel encoders both for the motor speed control, but then another program might also want to be able to get the wheel encoders in order to figure out where, for the odometry, so the robot has an idea of where it is. So one of the nice things about this is it has a really simple ASCII-based publish subscribe system. Subscribe means open a TCP connection. It also has a TCP and ASCII protocol to let you get and set parameters inside your running program. It turns out that the ASCII protocol to get and set parameters inside the running program is the same. The commands are such that down the TCP connection,
By now, everyone's connected. We'll communicate.
Oops.
And those are two pallet roles.
I'm going to erase this.
Yeah, they're just because of the fact
down the TCP port, you'll be issuing commands. There's only a few, but one of them is empty daemon set. Then this is the name of the plugin. In my case, it's the name of one of the devices on the robot. Mode in this case is the mode. Is it forward? Is it reverse? Is it brake? Or is it coast? And we're setting it to forward. Well, it turns out it's really easy. If this is the command, it turns out it's really easy to make this an ASCII or a bash command as well. So the protocol that you're sending down the TCP connection in the program that you write is exactly the protocol you would use sitting at the bash prompt to experiment with it. So there's a one-to-one correspondence. It makes it pretty easy to learn. Now let's take a minute and see if this will come back. There we go. So the first command is edlist. Edlist, by the way, if you have an open connection, you've done this, yes? Go ahead and give it a try. Edlist gives you a slot. The plugins are numbered, and you can address a plugin either by the slot number or by the plugin name. All right. The next thing it gives a brief description of what the plugin does, and then these are the names of the resources that you can get or set or cat. Sir. 88. Oh, I'm sorry. Yeah. 8870. 8870. None. It's straight ASCII, so there's no escape codes of any kind. Yeah, that's a good question. A new line. Just a new line. Yes. Yeah.
So I get an error on the one that recognizes men. I need an example of one that lists
EDLIST return. Does it work now?
except for the new line issue.
Well. It turns out in this list, the resource is given, and then what commands work with that resource. So if you were to do an ed get space and then either 8 or GPIO4 and then pins and hit return, it'll return the value of the pins at that moment. Why don't you try that now? Would someone give that a try and let me know what you get? Okay, ED. So this one sets the value. ED set, the module name, GPIO4, the resource, interrupt, and F. So actually, we need to do this. Would you do an ED set GPIO4 interrupt F? That turns all pins into interrupt driven. And then would you do an ED get GPIO4 pins? And what do you get? 0. Yeah, that's because in the time difference, I hit the switch. So if you do it now, you should get a 1. Yeah, and now 0. Because it turns out that the pins are something you can get if it's an input. You can set it if you configure the pins as an output, or you can monitor it. It's something you can open a file descriptor and sit there waiting for data. So let's go ahead and do this one first. Would you then do some of these things? ED cat GPIO 4 pins. And what do you get? Nothing, right? Okay, and now if you watch the input, you're seeing all the things come in. You have now just subscribed to the publish system of, so what we're doing is ED cat, this right here, it says that the pins resource works with ED cat. That means it's a broadcast. You can broadcast it. This ED cat means it's a publish subscribe publisher. And if you're watching, if you've done an ED cat on the pins, you're seeing all these switches come in. All these switch bounces come in. Yeah, good question. Having led you down this path, it turns out you can't, and that you have to close the connection. Yes. Which is in a real application, that's actually, once you set, at least for robotics, once you set everything up and you're watching for switch closures on the bumper switch, you're not going to suddenly decide you don't want to watch for bumper switch closures. So yeah, just close the connection. So you may run that again. Would someone be so kind as to ED cat IRIO or 9 RECV? ED cat infrared input output the receiver. Yes, in fact, no, that was actually my intent when I started this. And
what's the coding for the keys?
I have no idea. So let's do. Now I'm doing this at the command line, but because I'm local, well, you can do it either. But ED cat. GPIO4 pins. Oops. There, ED cat. IRIO. There we go. Actually, we have two, so.
Oh my God, so what's going to happen? Are we playing war here? Or?
Yeah, I mean, you can collide, but it'll try to serialize them for the most part. And ED, oh. So on the quadrature, I want to set the rate. So it's on resource 2, the update rate to 100 milliseconds. D. All right. All right, so what I did was I set the PWM frequency for the motor controller to 10 kilohertz, pretty common value. I then set the speed for motor 0 to 65. That's 65% of on a PWM signal. That actually looks a little slower than 65%, so someone may have set a different value. Would someone please do me a favor? Would you set mode 1 to forward? So this is the command, ED set dual DC motor controller, the mode for motor number 1. All right, and now would you then set the speed 1, to something like 50 maybe. All right, and now here we are. Arg. Someone, it looks like one of them's in forward and one of them's in reverse, so which is fine. But so now imagine you're a program and you've got 2 TCP connections open. What you want to be able to do is to issue this command. So down one TCP connection, you're issuing these commands, ed set DC2 speed 0 to some value. And in the other TCP connection, you're pulling in the values and you want to slave the two. You want to build a control loop so that you get the speed. In fact, let's do that. Let's try to get the speed, this 473. Let's try to get that to match the 360. And you guys can do it, you know, you won't collide, so it's okay.
So I'm sorry, would you be subscribing to the first motor and using that to drive the second motor's speed?
Well, in a robot, this is application specific, robot specific. Normally, you want to control both motors at the same time. You're actually aware of both of them at the same time. So the same program that is watching this is actually issuing control for both speed 0 and speed 1. So it makes sense to get both speeds at the same time. Did I answer that question? Or maybe...
Sort of and sort of not, okay. If I wanted the robot to go straight,
yes.
the logic would not be that I'm sending the same command to both the motors. It might be that I logically wanted to go straight by saying I want the motor to be the same on both, so that if I set the left faster or the right faster, it would still go straight.
And in fact, that's exactly the control loop that someone had started, right? It turns out that one of these motors is a lot more efficient, easier to turn than the other motor. So if you want to get the robot to go straight, these two numbers have to match. And you do that in a control loop. You write a program that does that. And it turns out to get those two numbers to match, you actually have two different PWM powers, because one of them takes more power to turn at the same frequency. And that's why you need to do it in a control loop. So.
To do that, how many of these connections would I need?
Two. You need one connection for everything that you want to monitor. All right. So you're monitoring all this stuff from a robot or whatever your system is, and so you need one connection for everything you want to monitor, and then just one more connection because you can send commands down this to control anything. Does that make sense?
Okay, one last thing. So I said that I want to monitor one of the motor's speeds. And you talked about publish, subscribe, right?
Yes.
Then I've also set some logic that says that when I get a change in the left motor, I do something to the right motor.
That's you would normally, if you get a change in the left, you would change the left motor, but you could. For instance, if you're during a turn.
Changes the left motor, and the overreaching criteria is I want the robot to go straight under all conditions. I would have a subscriber to the motors, and then whenever anything happens, it gets notified that motor speed is changing. It adjusts the other motor to sync.
Yeah.
I need more than one terminal to do that.
You need.
Send out two commands on the same terminal. That should be fine, right?
That's absolutely fine. In fact, from this, you can get to any of the devices. So you have one TCP connection to subscribe to everything you want to subscribe to. All right. In this case, we have 3 different sensors. We have 3 different TCP connections to subscribe to those sensors. And then you have one more TCP connection that you send commands down. And you can do this with multiple programs. You know, the empty daemon defaults to 8870, but on the command line, you can set whatever port you want. So you can have multiple instances of this. Yes, sir. Yes.
Can you do any of this under program control? Like a master program that would send out commands?
Absolutely. And in fact, that's specifically why I wanted you to use Telnet. You're using Telnet. Now, I did the commands here, but the idea of using Telnet is you're pretending to be a program that has opened up a TCP connection. So now in comes a line with 2 zeros on it, and you do a F-scan-F on that, and now you've got the motor speeds. So that's the whole idea. And the thing about the empty daemon is this kind of comes for free. I mean, you get all of this. You get the ability to set values, to get values while the program is running. That's actually really valuable. You know, if you're tuning, in my case, a PID loop, the control loop, tuning the parameters, it was really nice to be able to play with the parameters in the PID loop while the program was running. You also get this really, it's ASCII based, but it's pretty simple. This publish subscribe system, which calling it a publish subscribe system gives it more weight than it deserves, I kind of think. Are there any questions with what we've got right now? So, you know, what I like about it is the whole program to do this, the core of it, there's only like 3 or 4 files. I think there's 3 C files and an include file. It's actually pretty simple. All right, let's go back. And I'm now going to shut down this system. So your connections will all break at this point. And we, sorry, was there? We saw on the other screen that the shell commands match exactly what goes down the TCP connection. So the protocol is, as we said, it's ASCII over TCP. In the demonstration that I just gave, the modules are loaded automatically. The FPGA actually reports the peripherals that it has built in, and then the program loads the modules automatically. So we didn't have to load the modules for this one. But in the empty daemon, you can actually, from inside the protocol, load a new plugin for the system. And we saw that ED-set, you can specify a plugin or a slot number, the resource and the value that you want to set to it. ED-set, it's not just parameters. So I've got a text LCD, and so I use ED-set to write data out to the text LCD. So it's anything you want to write. It doesn't have to be a parameter per se. ED-get, it's the same thing, but you don't need to specify the value. ED-cat is how you, I mean, it's from the command line. It's how you subscribe to something that's being published. Typically,